source projects, and also other cloud technologies. She's also the president for Chicago Java User Group, which is more like similar to our user group here in Cape Town. And also she does some live code twitching stream, and also she writes or publishes some blog posts on various technologies, architecture, and all those things. And she presents also in many user groups. I think now because of lockdown, since the meetups are mostly online, I think she's presenting, I don't know how many across the whole world. So she's a very busy person. Oh. And also she does encourage women as well to participate in the field of mathematics, like what we call STEAM, and also presents at other more like annual events for small girls to encourage women to participate more in the IT industry. So yeah, I think this is just a brief of what she does. Her profile is big. I think she can even give more info on it. So Mary, welcome to Cape Town. And yeah, over to you. Looking forward to you sharing the knowledge. It's such a pleasure that you accepted our invite to share the knowledge, and we really appreciate. So over to you, Mary.
Thank you. Thank you so much again, Stephen. And thank you, Herman. And I wanted to, again, mention earlier, too, I mentioned about how Stephen was very persistent coming after me. And I've had to kind of apologize because of I'm just like too much stuff going on. So it was a bit of a delay until now. So I'm so glad it's actually happening. And of course, too, I wish I could be in Cape Town in person. I've heard good things about it. It's beautiful. And the picture that Stephen has in the background, I wanted to be there. So hopefully in the future, I'll have the chance to visit your country and see the beautiful landscape and everything too, all the stuff. So yeah, so thank you again. And thank you again, Herman, too, for allowing me to be here, this opportunity. So yeah, so I'll share my screen now with my slides. And if you can give me a minute, I'll just share that, making sure I can do it. Are you able to see my screen? And also I'll run the...
Yes, we do.
Okay, great. Yeah, and let me also then run it's always kind of, when it comes to, okay, I cannot get to my, okay, get to my, I'm trying to get to my, this here, so then I can play. Okay.
You can drag that bar, the Zoom bar, around to a different location.
Yeah, that's what I thought too. It's always been kind of annoying, but okay, thank you.
Yeah.
Okay. Thank you so much. So yes, so thank you. And I know too, just let me make a note too. I know when Stephen first spoke with me about coming to speak for your Java users group, Java community, he mentioned specifically about reactive. And that's actually the topic I was doing at IBM for maybe a year and a half or so. And that's where I met Stephen too. And we met at a conference where I presented reactive. But since then too, I joined another team, or kind of more like transfer. So now my focus has been more into OpenLiberty Kubernetes, but it's still primarily Java. So I'm still developer advocate. So as such, yeah, so I wanted to thank you again for kind of inviting me here. And just give a bit of a brief introduction, and thank you again for Stephen for really nice that you introduced me to your group, and really appreciate. So I'm senior developer advocate at IBM, and so now with working with more focus on projects are OpenLiberty and Microprofile and Jakarta EE in that area. But still, I'm still kind of broadly speaking, it's still Java, open source, cloud, DevOps, and enterprise distributed systems essentially is my area of interest, and of course reactive too. So I look at technology as more like a tools for us to solve problem is what I'm looking at, and I'm not like biased towards one versus the other, but just so happen have been working with Java, so that's the area that have been working with. I have over 25 years of experience in software engineering, and that's kind of before I became an advocate at IBM in 2018. So it's just a wide variety of technology that I've touched on, primarily like enterprise applications. I've also done some product development with another company called Sybase, which is now part of SAP. So I worked on the app server group too. So now it's kind of natural. I go back to working with more app server, although we call it OpenLiberty, for example, is more lightweight, cloud native ready server. Okay, so outside of work, I'm a Chicago Java Users Group president, and also I help with different IBM sponsored meetups too in Chicago. So, and I have a butterfly, because as advocates, we're kind of like social butterfly is part of our job. We need to like go and talk with people and kind of just build the relationship. So I'm kind of in general a very busy person, but I really love it. The thing is that I really love is to meet people. And I think traditionally for developers, we tend to be kind of less of outgoing. I have to say too, in some ways though, I'm actually very introvert in some ways, but at the same time, I also enjoy people. So I'm kind of have this weird mix of extrovert and introvert, but I do enjoy the outreach work. So thank you again for the opportunity. So, okay, and let me go. Okay, so now today's topic is on stateful microservices, but I promised too, Stephen, since you mentioned about reactive, I'll also talk a bit about reactive, because these are topics like this topic areas too, and reactive, they also have very close kind of shared kind of goals in both of them. So I will also be talking a bit about reactive. So, and also too, just a note too, is that I'm like less about like talking about, okay, teaching you how to do this, 1, 2, 3, like all the steps, but I will do some, show you some code. And so then you get an idea. And also I have to assume too, maybe not everybody has worked with, this aspect of microservices. So I may be touching upon some of the basic concepts. So pardon me if you're already familiar, but you can also tell me too in the chat if you want, if you find the information is a little too easy, or, I'm going too slow or too fast or something, just let me know. So feel free to also send me questions as we go along. I prefer more of an interactive experience, and as such, we're all learning. We're on a learning journey. So, okay, so as such, stateful and stateless. So to me, I feel that when it comes to like stateful apps, it seems like it's not something that if you go search, it's not like JavaScript, any kind of like popular things that are out there. And the reason is that I think stateful is actually a very important subject matter, but maybe too is that it's hard to do. So I think the whole general market, the way we're going about doing things is we always tend to talk about things that are needed, that are more like easy to, I shouldn't say easy, nothing is easy, but a little bit more straightforward perhaps, or less convoluted. So then people don't talk as much about stateful. So there's also a need to be clarifying that. So now for that, and I like to actually first, do a bit of talk about some analogy. So what is it, right? So now assuming that you have seen the movie, maybe some of you call Finding Nemo, and if you haven't, I'm just going to repeat a little bit. So as you know too, is that the little fish, right, Nemo, got lost, and actually was kind of, I forgot exactly, but anyway, he was lost or got trapped and kind of got into, essentially got caught and then like pulled away from his dad. And both himself and Marlin, the dad, were like both kind of left, from the same family, all these things happen. And so they were kind of helping each other out. But of course, the father was all frantic because Nemo was gone. And so he went on this journey trying to look for him. In the meantime, then he met this fish, Dory. And Dory is a very forgetful fish. So in some ways, I'm using this analogy because I just wanted to point out as such too, if you kind of look at, this analogy of Dory is the stateless representation, and then Marlin is the stateful, then there's a lot of interesting kind of, what you call like a contrast between the two, because while they were going on the journey, Dory, without any memory, she would always go and jump and do something. For example, they saw like a group of jellyfish. And so she was like, oh my gosh, they're so cute. She jump on them. But of course, jellyfish, they sting. So Marlin would be like warning, hey, don't do that. You're going to get hurt. And Dory is like, oh, I don't care. But, if you go back to computing, then it's stateful versus stateless. If you think of it like that, though not exactly, is that if, in stateless computing is that we don't actually worry so much about memory. We don't worry so much about what happens before and after. We do not keep track of the state. So it's a lot more agile. So in some ways too, it's basically one of the mentals of today's cloud native world. So cloud native is meant to be very agile, very fast, and containers are stateless. And so in some ways too, we're like comparing stateless, using Dory to compare, is this stateless. And whereas if you are stateful, then you kind of carry with yourself a lot of, all the background, right? You need to know if you kind of, a system transition between state or different events that are happening, you want to keep track of every single change of state. So it's just a lot more baggage to carry. So let's take a look, right? Computing life used to be simpler. But so I'll just kind of lay it out, stateless computing. So what is stateless? So it means it's a communication protocol that does not retain any session information. So basically the change of state of your data during any kind of workflow. I think all systems essentially, especially in the business world, deals with like business operations. So it deals with a lot of workflow flows from here. For example, in an e-commerce system, you have order entry, orders come in, and then in the meantime too, then there are payment components to take care of all of these things. So all of these actually does require state. But whereas for stateless is that while we don't care, we don't record. It's more like we need to do this, we'll do it, and then we're done. We don't remember things. Now, as a result too, then architecture design implementation is a lot simpler. You want to scale the system also much easier. And say, for example, you need to, you have more in an order entry, for example, in the stateless way is that if, you need more orders than processor, then you can always like increase the number of processors to process that. When it's done, you kind of shrink it back, and that type of kind of idea. And then if there's system failure, it's also much easier, because if your node goes down, then all you do is spin up another one. There's no need to reinitialize it to the state it was before or with the failed system. So that's the idea of stateless. So it really suits very well for a cloud native type of environment. But realistically, too, we live in a stateful world, as I mentioned about, we do need to remember things. I mean, it's, then otherwise, the flow would never happen, right? Any kind of, long running kind of transaction. So as such, stateful is kind of like juxtaposed to stateless, is that it's a communication protocol that will retain all session information, right? And we need to record all of the steps across all transactions, and it, your whole. And then in today's world too, we're living in very complicated world. And as such, all systems are distributed systems these days too. So we need to be able to capture all of this information. And I think with the cloud computing is that it's making, today's world with all the containers is making it more complicated, because now we're talking about, you're like having clusters that are, multiple nodes and things like that. You do need to make sure all of these nodes are all in sync. So you can imagine, right, it is a pretty, not a very easy task. So if you want to scale it, it's much more difficult. If you want to add, add any nodes to it, you want to make sure that the new node would need to be synced up with the rest of it. And also if you need to recover, then same thing, if you need to, spawn off a new node because to replace something that kind of crashed, then you need to spend time, to kind of spin it up. So as you can see too, it affects system performance as well. So that's a bit of a kind of the thing we have to kind of consider. Okay, so let me kind of go into like statefulness in the cloudless days. So yeah, so when we talk about cloudless, right? So before all the cloud, client server system. So how did we do it, right? So let's kind of recall a bit. So back then too, if you're kind of before the cloud days and there are client server systems, so clearly client and server. And so one of the things, of course, too, is that we rely on the database, on the server side, especially. So there are database styled transactions. You start a transaction, start transaction, you do a whole bunch of stuff and something goes wrong, then there's a rollback. So usually it's provided by your database too, or how you configure it. You can do the database itself, kind of the framework of the database, manage it, or you can also do like user transaction to manage those. So that's a way of managing states. And of course, too, in a distributed systems in which applications, especially if they span across multiple databases, then there are also two-phase commit. If some of you may have worked with that, but if not, it's just a quick intro, is that two-phase commit is essentially, it requires a coordinator to kind of be the one that kind of like, kind of overseeing all that is happening. So each database has its own tables and all that stuff. And you have multiple databases. There are not just multiple instances, but you can have like multiple flavor of the database too. It could be a Sybase database, an old, Informix database, DB2, all these things. And they all are processing something. So the coordinator will be there in the middle to kind of be kind of the judge too. Every time you're looking at a complex business flow through all the systems. They all have they're associated with different databases and all these things. And so at the very end, you do need to commit the transaction. So it's up to the coordinator to go around and kind of ask Oracle database, are you ready? So they said, I'm ready. And you go to Informix and said, are you ready? And it's ready. So then you ask all of them, it's all good. Then you kind of, see the first phase. And then the second phase would be like, okay, we're all good. Let's go and commit kind of thing. So that's kind of how it was used to be done. And I believe there may be still, kind of systems that are doing that as well. And also too, I think some of these are also being kind of the approach is also still being used, I think, in the new way too. In some sense, it's not two-phase commit so much, but I will touch upon the new design pattern to cover that. And then there's also like on Java side, right, your application side, and there are enterprise Java beans. There are also stateful EJB as well. So that helps in preserving state, small and application level. And of course, too, there are servlets in which we are also utilizing HTTP sessions. So these are a lot more specific on the transport level. You have HTTP session, you have servlets that actually helps with like maintaining state, during your whole transaction, the interaction in your application. So, and then on client side too, there are also like client side caching of like server responses, for example, like cookie-based authentication, and also like token-based. So that's a very common place today with web apps. Then there's like the JWT, JSON Web Token too. So as such too, just a quick thing was that cookie-based are still being used, but as we can see too, cookie-based is a little bit more performance involved, because when you kind of, have to like send requests from the server to, from the client to the server, then you send the cookie. And basically you do need to make multiple trips and multiple, it requires multiple steps, because you do need to send the ID, the session ID to your server. So the server then looks up and say, okay, well, you are the right one. And of course, all these decryption and all those things that are assumed there, which I won't talk about. But once you kind of take your session ID, it's good. Then you basically have to make another call. Then with the session ID, then you do need to make kind of send your request like through a REST API and make another request. Whereas for JWT, then you usually you can wrap your whole payload too that includes the ID, session ID, and you go to the server. And once the server gets the verify the session, the token is good, then it kind of goes ahead and actually make the request for you, that type of stuff. So anyway, so that's a bit of the, more traditional way of how, state are being managed. So these are kind of the ways. So, okay, now, then we kind of move more into the stateful microservices in cloud native environment. And as such too, cloud native, it's kind of like the thing of, the new thing now, as we know. And what is cloud native, right? And also too, first of all, is that when I first learned about cloud native, and it's kind of the all of the guiding principles, which actually essentially is the 12 factors, kind of what you call 12 factors guideline, right? And that one I actually will have another slide to talk about it. But they basically are pointing to more of a stateless approach. All your containers needs to be, up and down really fast, and so as such has to be stateless. It doesn't keep all the states it's supposed to be, right? And also other kind of thing that points to it being like, cloud native should be, has carry with it more of a stateless type of flavor. So how do we preserve state, right, across all of these, these complex like ecosystem like that? So, okay, so then let me also talk a bit more about cloud native, right? So cloud native computing essentially is an overarching approach, and it's essentially really an extension to cloud computing. I think it's already confusing enough when I first heard about cloud native. I think the term too was actually coined by Netflix, because as such, right, Netflix, it's very advanced, among a lot of vendors too. And it's also the nature of their business. They need to be streaming. And of course, like if you're streaming media content, video, all these content, right? They need to be very fast and everything. So, and they are already kind of ahead of the game. They coined the cloud native term in the early 2010s, and they wanted to leverage on the cloud to meet their goals. So they have laid out the 3 of their points: is that the system needs to be highly available and very scalable and very performant. So in there too, in fact, that's where I'm going to branch off or kind of veer off a little bit and point out these 3, to me, they are, kind of also share the same goals as reactive systems. So I will also talk a bit about reactive systems. So essentially the scalability, the high availability, and kind of responsiveness too. So that's cloud native. So without kind of veering off too much, but I just wanted to point out, so cloud native is essentially you're leveraging on the cloud infrastructure and kind of, leveraging on it and to achieve the goals as laid out in here. So to this day too, it's still the goal of cloud native, and it's also as such too, or at least the area I'm advocating for is really more for the enterprise environment that are distributed, and they're helping with business in their operations in that area. And so now then there are also a set of guidelines, right? 12-factor application. So it's basically drafted by developers at Heroku, and it gives a set of guidelines, and they're essentially best practices for portable and resilient applications that are well suited in the cloud environment. So one of the factors indicates basically the need for self-contained services, which are to be deployed as stateless processes. So essentially, microservices architecture is what it is kind of pointing to on an abstract level. So microservices is kind of like goes hand in hand with this cloud native kind of principle, essentially. But it doesn't enforce, 12-factor application doesn't enforce the tools or libraries, So today, the example I'll be using is Java, but of course you can use other languages, and, there are also like JavaScript, Node that is doing that, and there are Python or like Go, all these things too. So, so it is basically agnostic to any kind of tools and libraries. And so this is kind of give you an idea too. So these are the 12 different factors. So as such, code base, it needs to be tracked, and dependencies and configuration. Now, another thing is interestingly too, is the configuration. That's actually, I think it's applicable whether or not you are cloud native or not, is that you really want to store the configuration separate from, for your environment, like separately external to your apps. And I think that's kind of good practice, I think so. But today's, I won't get into that, but there are also lab exercise too that I can point you to, like, let's say leveraging on micro profile. There's also configuration that helps you with that. Okay, and then there's also like, the 4th one is backing services and build, release, and run. So as such to cloud natives also very DevOps kind of related, right? And the processes too over here, like point 6 that's the one, is that execute the app as one or more stateless processes. So, and then also like port binding concurrency. And so that helps out, that scale out, via the process model. And disposability also is another point in which is basically you maximize the robustness of the fast startup and graceful shutdown. So in other words, as you can see too, it's really cloud native is geared towards more of the stateless way of doing things. And then the rest are like dev prod parity, logs, and admin processes in those. Okay. So now the question then is that, well, in a cloud native way, then how do we preserve state, right? Across session, across transaction and network boundaries. It's actually a very difficult computing problem to solve. I think, it's one of the challenges of distributed systems, and it's really complicated by this cloud native environment that we're living in today. But the thing is too, it is also like an area, it's like a gold mine, there's like so much potential in it. And also like, opportunities for us to be creative to see how we can solve this challenging issue, right? Or not just issue, but this kind of a challenging problem that we need to be solving in today's complicated world. So, okay. So let me kind of get into it a bit. So techniques, right? The mechanism in doing stateful will be like caching. I think so. I have an example too to show you. It's basically leveraging on OpenLiberty. And by the way, too, if you're not familiar, OpenLiberty is a open source runtime library. And essentially, too, it's a WebSphere, but it's the open source version of WebSphere from IBM. Now, as such, it is open source. So I'm not here to say, okay, buy this. That's not my goal. But as I am also like still new to the team, I've been with the team for 2 months, a little over 2 months. It's actually very flexible systems. It doesn't force you to do things a certain way. You can be very flexible. I think that's really the biggest strength of it. And it also conforms to guide or specifications, the Jakarta Enterprise Edition. So the Java Jakarta Enterprise Edition version. And lately too, it's been Jakarta EE came out like version 9. It's also already been conform to that. So it's a good thing. But anyway, I didn't mean to digress, but talking about the techniques, there's like caching we can do, right, to maintain the state. And then database style transactions too, that's still very valid too. We can still leverage on those. And there are also like cookies and sessions. So we're then dealing more on the session, like per request type of level, you deal with this, maintaining state, using those techniques and tokens, right, JWT and all that. And then, of course, too, now with cloud native, it's getting more complicated because then now we have our apps actually deployed in containers, and they're like in a cluster, and they're and very popular way of doing it is to use Kubernetes, and as such too, if you want to like do to maintain like state on this level, the containers orchestration level, Kubernetes will have this stateful set kind of capability to it too. And then there's also persistent volume and also the cookie affinity to that too. So these are like on the cloud native kind of level. Now, the thing is, I just thought I brought more to your attention is basically, if we're on the development level, right, the application level, and as such too, actually today, I won't be talking as much about the on the Kubernetes infrastructure level, rather I'm bringing, highlighting a bit on the programming design pattern level, which actually a very kind of a popular or gaining popularity to help with like long-running transactions would be the Saga pattern. Saga essentially too, it helps with managing transactions in an application that span across multiple services. So that's the pattern it uses. And if you kind of visit Chris Richardson, who is a well-known figure, right? A speaker in the microservices world. He also documented this quite well. If you go to microservices.io, he kind of discusses in length too about Saga pattern. And of course too, there are also other well-known computer, kind of leaders too in the industry. For example, Martin Fowler and also Sam Newman too. They also have kind of published articles on Saga too. But like I said, I just wanted to kind of bring this up. And so basically too, with Saga is that you're like, rather than saying that you're having your, application as the kind of just treating them as like single component and kind of like managing your transactions is basically we're looking at the system as a whole. So, a set of activities are being grouped into like, a particular kind of component of it too. So now the idea is that if you want to do rollback, and there's no such thing, so to speak, as a rollback, not exactly like a database kind of concept, rather it's actually called compensation. So if something, kind of you're trying to, let's say, it's always like doing an e-commerce system. So maybe I should kind of bring up an example. Let me kind of quickly switch over. I find that I am, like I said, because I lost a bunch of stuff, I'm so sorry. So let me kind of share with you as such. And are there any questions right now? I didn't even check to see if there are any questions too. But it doesn't seem like there is, right? There's nobody on the chat. So, okay, just wanted to make sure, but let me do this one thing, and I won't maximize this, but I will bring in a project that I'm actually working on. And as such, you bear with me because I cannot, okay, so this is good. And oh, you know what? Because I have to end the show, and then I can bring in other things to it too. And why? Oops. Are you able to? Oh, I'm actually trying to bring the. Maybe because I need to.
Oh, just
okay.
just.
Yeah.
Yeah.
Because I thought maybe I didn't maximize it, but okay. Okay, so I just wanted to kind of quickly kind of show you too of a Saga pattern, and it's something I'm because the topic is a bit new to me, so I haven't had it implemented yet, but I wanted to show you as such wanted to explain, right, using a Saga pattern to do some work. Let's say a good example would be like, you know, to illustrate, right, using a shopping cart. So the idea is that okay, for Saga too, as such, there are two types of Saga pattern. One is called a choreography Saga, and the other is orchestration. So this particular case is that I'm doing is a choreography event driven. So as such too is making use of event driven approach. Now, so that's the thing is that I feel that there are a lot of kind of synergy between this approach and reactive. Now, while this isn't quite exactly reactive, but certainly to reactive borrows a lot. And the idea is really reactive, asynchronous kind of approach. So I see both having this synergy. So as such too, I just wanted to kind of explain. So a simple case, right, of an order processor. So again, this here is simple. So the order gets generated. So for now, right, we don't worry so much about implementation, but we can kind of treat it like, you know, an order events get generated perhaps on a Kafka source. So then basically with that Kafka event, then basically that kicks in my order processor. So the order too will then flow through the system. So of course you receive an order and it generates a order created event. So that event too will then trigger. I need to check, for example, the inventory, right? It's a typical e-commerce system. You do need to check the catalog to see actually if you have the, you know, somebody placed an order, but, you know, maybe you don't actually have the, you know, the item is there. So there's also like inventory check that's necessary. And of course too, then there's also credit check too. So somebody, if you go through, you know, e-commerce, then you have to give your payment, usually is credit card. Let's say we use the credit card example, then we have to do credit check. So these two are being triggered by order created event. And then, of course, too, then you go, let's say, you know, you go in here. So when inventory checked, it passed it, then you see that there's an order inventory checked event that will then trigger the next kind of step in your flow, which is a payment processor. And then same thing as credit check to an order credit checked will then also trigger this payment processor. Now, this part I haven't like exactly iron out all the details, but as you can see too, is that payment processor can only be happening, you know, kicked in is only if both the order inventory checked and the order credit checked are both passed, you know. So over here too, actually, I didn't say is that after you do payment processor is that it's actually, this would need to also go back to the order because the order status will then needs to be updated too. Now that part I haven't kind of get it so detailed is that the order itself would go through the different change of state, right, of your, you know, the processing. So you can have order first, it gets created, open it, and then basically order then, you know, actually I should say order created and then order open. And then at that point, you know, it's like after all of these check and then over there, it's good. Then you go in fulfillment. And then after that, then it's basically if it's paid, you know, after the payment processor, an order paid event will then trigger the shipping processor, which will be then yet another system to do it. So, okay, so this is just a very simplified kind of high level explanation of, you know, using a Saga pattern to do that. And just want to kind of give you an example, you know, the area of application of like using stateful microservices. So I hope, you know, this one is helpful. So just wanted to share with you about that. And like I said, over here too, I wanted to also point out, and let me kind of get back to here and run my from current slide. Okay. And let me put this back. Okay, so just now we took a quick look in choreography saga, and right now I do not have an example of an orchestration, but wanted to explain is that for orchestration, to me, it's a bit more like a two-phase commit because it involves, not that it's exactly the same, but orchestration essentially will bring in the broker. So it needs to have something like a middleman needs to be there to handle all of the parts that are happening. It needs to deal with that. That as such, as you can imagine too, having an orchestrator will kind of definitely be complicated because not only are you dealing with, each part, you have to, in some ways too, also have to explicitly deal with the timing of each. And not only that, there are also like multiple nodes too, for example. So I think that would be an interesting experiment, which actually I hope maybe that my next project after I get the choreography sample, then I get into orchestration, because then how do we also orchestrate with the application level and then also like with the infrastructure side of things too. So. And when I welcome your ideas too, if you have any. Again, these are like newer concepts that are yet to get tapped into. So, but want to share with you, the exciting thing. So, and then another thing I wanted to point out is this long-running action that makes use of Saga interaction pattern too, and it also makes use of a compensator model. And I wanted to point out too is that in MicroProfile, which is also another open source project, comes out of the Eclipse Foundation. There's a working group, right? So it has LRA. So they are actually working on it, and it's just recently released the long LRA 1.0 as well. So I have also a link to that article that you can also read about if you're interested. So again, going back to compensator model. So what it is happening is that if you, and also I didn't actually talk about is the fact that, during the course of your whole flow, then another pattern that is also being used is actually the event logging, event sourcing way of doing things. You might have heard of is that, instead of like storing the state, of your order inside strict kind of like straight into a table, you want to actually keep track of all of the events that are happening in the course of your flow. So then every change of state, you log that information into the database. And so you are not actually storing the actual order with the status at that point in time, but you're actually storing all of the change of state. So then if at any point in time, you can go back to your table and do, sort of like a compensation, because then you can kind of look back and say, well, something goes wrong. I need to compensate. I need to kind of go back in time and kind of take that, previous state, and it's essentially compensated. It's kind of restore what it was before the transaction begins. So that's kind of the idea. So, but that's kind of an interesting area, which I don't have enough time to get into all the details. But I have information that you can also kind of go into reading further too. So. Okay, now the next part is then about reactive, and I promised Stephen was saying that talk about reactive, but as such too, reactive, right? I just want to kind of quickly point out, and as such, cloud native, when I mentioned about the 3 goals of Netflix had, for cloud native, to me, it's kind of intersects very well with over here, responsive, right? Very responsive systems that are highly performant, right? There are no, all of the requests that comes in needs to be processed in a timely manner, and that's a reactive, one of the guiding principle. And then there's also elasticity. So that also maps to the highly scalable goal of cloud native. So if there are more requests coming in, then your system needs to scale up and be very elastic. And if you don't have anything going on, you do want to scale it down. And that's actually absolutely important too in a cloud native environment, because when you think of it too, right, a lot of times we're running our system, right, that are being deployed onto like publicly managed cloud infrastructure, or some of them are like hybrid cloud. So you are being charged, because there are different data centers that manage it. So you can imagine too, they charge you by how much resources you're using. So you do want to make sure that your applications are very efficient. You don't waste any resource. Every time you are running something, you use it to the max, and then you kind of basically idle it or somehow like stop the processing if it's not needed, that type of stuff. So elasticity is absolutely important in a cloud native kind of context. And then another thing is basically the resiliency part is deals with recoverability that reactive systems have. And so is cloud native. I think any systems too needs to be very resilient. It's like if one parts go down, you want the overall system be able to compensate, right? To kind of like have replacement for that node that went down immediately type of thing. So that's reactive. And then like with reactive too, there are the 4 tenets. The other thing is basically the message-driven aspect. And to me, I always look at message-driven is more like an enabler, without which too, then the rest of the 3 aspects wouldn't be possible. Now, so here it is interesting. And I feel myself is also maybe trying to come up with like a good overall kind of tie into this theme of reactive into cloud native and into stateful microservices. I hope I'm not confusing all of you, but I find it to be quite interesting. And the reactive side of things, as you can see too, leverages a lot on, in fact, is all about event driven. And reactive also too, another thing about reactive is the fact that it deals with only streams, data as streams. So as streams too, then in a simple system, that's okay. You have like, you can just have a few streams, but actually in at least theoretically, is that streams, you can have like many streams of data pouring in. So let me give you an example, right? So reactive streams processing in an Internet of Things type of scenario, you can have like a field, a farmer has a field and a couple thousand acres, and you can be installing different devices, right, that are in IoT devices all over the fields, because you do need to collect the weather information, things like that. So as you can see too, it could be like up to 1,000, and they can all be sending as a big storm pass through, and you want to make sure that if the water that you're measuring is over a certain level, you want to send some information back to the server. So in that case, a big storm pass through, you kind of pouring rain, it can really fill up really easily. It needs to send all the data back. So you can see too, the streams, it can create like a back pressure type of scenario. So that's the thing too about reactive, is that there's also a reactive stream specification that actually helps with, it provides the guidelines for library implementations to follow in which you need to manage the back pressure kind of thing. So as such too, reactive is very much a kind of a publish, subscribe, dealing with streams kind of aspect to it. So, okay, so I hope that also gives you a bit of an introduction to reactive, and I hope it isn't like too confusing, but okay. And now then, I think is my time good? Yeah, I think my time is good. So, okay, so now I'll go into a bit of code samples. I mean, as such, as developers, we're like, we don't want to just have talking, right? Let's look at some code, before. So hopefully too, this will be helpful. And I'll quickly show you too. This particular, the first example too, is basically OpenLiberty session persistence and using JCache and Hazelcast. And as such, JCache is basically implementation. Well, actually, I should say JCache is one of the specifications of the Java JSR, right? JSR, I cannot remember exactly what it stands for, but the Java specification, right? They are labeled by JSR, and I'll just look up, but I sometimes just cannot remember exactly what it stands for, but it's the specification. So, and basically we're here using Hazelcast as the provider for the JCache in here, is maintaining like session persistence. So if you're interested too, you can go to my this particular GitHub location, and that's where I will be showing the code, and then we can quickly kind of run it and kind of show it too. And then another alternative is that if you want to get your hands into playing around with it, and in fact, OpenLiberty too, we have a set of guides, and and this is actually where it came from, is from one of the guides. You can actually follow along, and right now they are pretty much, the guide is hosted on the web, and you can then clone it and play around with it in your local environment. Later too, we will actually be having like cloud hosted guide that you can do more interaction too. But for now, this is local. So, okay, so let me kind of go into here. Oh, and another thing is that we also have another example. And this is a bit of a, kind of an elementary example, but nonetheless, it's demonstrate to using stateful Kubernetes. It's also a demo too, if you're interested. So if you go to this particular URL, you can look at it too. So, Okay, and I'm just gonna like end the show right now, so then I can bring in my IDE. So yeah, and let me see, are there any questions? I don't see any thing on the chat. So and I think I have about maybe 5 minutes or so, right? 5-10 minutes or maybe less. So then I leave some time for your question too. Okay, so let me kind of bring in my, I do need to minimize this. Okay, and I'll just kind of, okay, so this is this, and I'll go back to this one. Okay, so if you want to follow along, you can go in here, but let me also quickly, oops, and you can see, I just want to show this. One thing to note is that if you want to take a look too at the rest of the OpenLiberty project, and also if you are interested, which I didn't mention yet, is that if you're interested in being an open source committer, as such, this is an open source project, even though, yes, it's primarily from, a lot of committers are IBM, but we welcome anybody to join and be contributor. You don't necessarily have to start coding a lot or something, but you can also be reviewing some of our materials and then provide feedback and all kinds of contributions too. So if you're interested, please feel free to join us too. So the URL is openliberty.io. And the thing, if you go to guides, wanted to show you. So this is like a set of guides too. They're actually quite comprehensive as a starter if you want to kind of take a look, and we won't have time to get into how to get started type of thing. But if you're interested too, you can also play around with the rest of it. But today we're looking into persistence and this one, the caching HTTP session data using JCache and Hazelcast. So that's the one. And so you're welcome to follow along too. And over here, this guide will give you that. And so you're welcome to follow along too, rather than watching or something. But let me also then, in this case, do a very quick kind of introduction. And I'm trying to bring my IDE over. So I've already like downloaded it, I've cloned it, and let me kind of like make it a little bit bigger. Okay, so now all of the guides too, by the way, there are two directories. If you clone it, you see that there's like a finish directory and then also a start directory. Finish is essentially the solution. So and because of time, I'll go directly to the finish directory, because this actually gives you the solution, but I wanted to kind of quickly point out a few things. So then it may be kind of give an overview. So before you start, or you can just follow along. But over here, I already built it. But if you take a look into finish, so essentially too, this example is a simple shopping cart. And so cart application, it's, if you look into it, as such too, OpenLiberty is also very lightweight. And also too, another thing to point out is that if you have a Spring Boot app, you can actually launch it into the OpenLiberty runtime too. So that's how flexible OpenLiberty is. So now I do not exactly have the example, but if you're interested, I can find out for you too how to actually do that. Anyway, so if you're doing like OpenLiberty, right, over here, we have our cart application extends application, and you can see too, it's basically for RESTful, it conforms to the JAX RS, right, specification. So, and, over here, like this, and then basically to, again, this is a very, simplified example. So I just wanted to point out that as such, we make heavy use of the RESTful services JAX RS to do some of these RESTful work. And as such too, this example is making use of the HTTP session and servlet requests and all these good stuff. And then we're also then making use of the microprofile open API annotations as well. So over here, so in this case too, is basically we can do like an add to cart example. So you, if you download the application, you can also take a look into it. So essentially, the path will map to your host, and then it will basically take in /cart, and then it takes in the number of item and the price. So just a very simple example of adding items to a cart. And okay, so all these things, as you can see, is over here, and won't go into all the details because you can also take a look into it. And then if you kind of wanting to take a look at what's in the cart. So get cart is basically takes the request, as you can see, get the session, and basically too is then we have our JSON builder to build the builder there, and then basically then you add the pod name, session ID, and all those things, and then basically too then it will print out what it is that are in the cart in this case. So okay, so we can also kind of take a look too at some of the other kind of setup that's required. So if you go to the POM file, the POM file will essentially have, I was going to say here. So all of these two, as you can see, Liberty configuration, this one here, we're essentially making use of the, how do you do like, separate out the configuration, right? From the environment type of thing over here. And then if we wanted to, in this case, incorporate a Hazelcast, a third-party library in here, and that's the one we're using, Hazelcast 3.12.6. And then the rest of them are dependencies. We are using Jakarta EE8 in here and microprofile 3.3, but actually microprofile is already up to version 4 right now, just so you know. And Hazelcast, and also then we have also tests using JUnit and also the Apache Crossfire 2 client for doing the RS, the RESTful stuff. And okay, so that's what it is. And so we'll take a look to Hazelcast too. We need a config file, and essentially too is basically naming our cart cluster in here too. And then, oops, I'll kind of move this out of the way. Okay, move it down here for now. And then Kubernetes. Okay, so the thing is with this particular example too, it makes use of your Docker, the Kubernetes that's local on your desktop. So if you have Docker, it does require Docker desktop if you haven't already had, but I think I'm assuming most of you have. So the thing is you can also do the the deployment to Kubernetes too. So that's provides you with the Kubernetes YAML file. And as you can see too over here, it's essentially the containers cart container. And we build the image cart snapshot. So all of these steps are all laid out inside the interactive lab too, if you're interested. So, okay, so, okay. And then of course too, you can see too, these are the protocol, right? For the port 9080 is actually, if you run it, not deploy it to the Kubernetes. And if you are doing on Kubernetes, then it's basically get exposed is 31,000 too. So, okay, so that's the Kubernetes YAML. And then there's also the server.xml, which is actually found. The server XML will be in the main and Liberty config, right? So it's Hazelcast and also server XML. So the server XML, then it lists out all of your feature manager. We have Servlet 4.0, Session Cache 1.0, JAX-RS 2.1, and JSON P 1.1, and the microprofile Open API 1.1 too. So all of these are like we can then essentially kind of in this case too is statically kind of identify it, but there's also like different levels of how the configuration information is being kind of prioritized too. And you can also kind of make use of, there's also a feature called microprofile config to help you with some of these external configuration, but I won't go into that detail for today. So I just wanted to point out to you. So these are the different, kind of mapping here for the Hazelcast, for our app context root and the port, and for the SSL port, and also the non-regular kind of non-SSL port. So okay, and then also too over here, basically point out too is the JCache vendor lib in here. So that's how we kind of refer to the Hazelcast session cache support in here. And then the JCache vendor over here, then yeah. So this whole section, actually, I should say, is all with the Hazelcast. So okay, so hopefully that's clear. So as you can see, not a whole lot of things. This is also a very simple app too. So Docker file too, that's also ready. So then it helps you with essentially to doing your Docker build and all those things. So, okay, so that's that. And how much time do I have? I just want to make sure, Stephen or Herman, do I need to stop or should I be running? Or maybe folks, if you like, you can also run it on your own too. But again, I wanted to kind of show some code to you. So then you can also then take home and work on it too. So yeah.
I think you can still go on around 5 minutes or so.
Okay. Okay. Yeah. Okay. Thank you. Yeah. I just wanted to make sure. Yeah. I didn't realize it's already time. Okay. Thank you.
Time flies if you go into code.
Yeah, exactly. Sometimes I didn't even think of it. Yeah. Okay. But thank you. Let me then go back. Maybe in this case, since we have the interactive guide that I was showing you, I feel that maybe I shouldn't be kind of spending time on this, right? So all of these two, just now I was showing you, is basically from this particular example. It actually has detailed explanation too. And it gives you, example of how you set up Docker if you haven't already done it. So I think it's actually pretty self-explanatory. But since I have about 5 minutes, I thought I still have a couple slides in terms of giving you the links and all those things. So maybe I'll go move into that part. But otherwise too, maybe the quick thing I can do, maybe one thing is, let me then, I like to sometimes use command line rather than using the guide there, or using my IDE. So, okay, so what is it now? Actually, okay, so because I also do a Twitch session, so I go by it because that way I keep one copy. So, okay, so this is where I have clone it. And so if you take a look, right, and you can clear it. Okay, so that's what I've cloned. So if I go into finish directory, and that's what I was showing you on the IDE, this is on the command line version. So all we need to do then to run any Liberty app is basically Liberty. Okay, then just a quick explanation too, if you are not familiar, you can do run. And also too, another option is to do def. And this is an interesting feature because what it does for def is that it allows you to do hot reload. So then if you are making changes to your configuration, then there's no need for you to restart your server, which is actually very nice. But I won't have time to demonstrate it today. But let's say, because def involves a bit more work, so let's do the Liberty run, and then we can then quickly bring up the client on the browser. So then you can kind of know what it looks like for this particular example. So yeah, that might still take a little bit of time. And so in the meantime, it actually may not be taking way too long because I actually ran it before. So a lot of things have already been downloaded, but otherwise too, if you're launching the first time, it would take much longer. Okay, so the server has been launched, but the thing with Liberty is that you want to look for this is the default server is ready to run a Smarter Planet, then you know it is up. So okay, so in this case, then what we can do, because I'm not launching in Kubernetes. So actually, let me kind of go back in here. It will actually show you too is that now this all the explanation, that's what I just talked about, and actually running it, right? So I'm actually doing just the Liberty run, and I can then do a launch. There's a 90, okay, you do localhost 9080 Open API UI. Oops, everybody. So it's actually not an issue. So, but here I'm actually supposed to be doing a magic show. But I told people too on Twitch too, it's more like the real case scenario. We're running into problems. Let's see how we can fix it. So, okay, let me completely actually replace this server.xml because I think I must have completely not, somehow, oops, and also too because I am I'm using a different Emacs keystroke, so I just wanted to anyway. But so I wonder if I have now fixed it. But basically, this kind of I got it back from the guide, right? So it's supposed to work. So let me do that again with the with my rebuild. Okay. Okay, I'm not sure. See over here, I'm not even sure like what's going on. Okay, maybe let me stop. Now, normally too, you can do Control-C or you can do MVN Liberty stop too. That will also do it, but we can run it too, but it's actually already stopped. So it should just say, it stopped and it wouldn't do anything essentially. So, so this will stop it. And okay, so build success is not running. So we can also do a def. So maybe in that case too, if any changes, then it should reflect right away. It should get picked up rather than us stopping and starting at once, kind of like that. So, okay, so. Okay, so. Okay, so I think it's at least I think this is okay so far. So okay, here we go. I think it might be good. Now the default server is ready to run a Planet. And as you can see too, with the def mode too, what you can actually do is that you can use the def mode, and if it's set up so then if you press enter in here, it actually will run the unit test for you too. So it's actually pretty nice. So but yeah, so that's the thing. Now with that being run, then we can kind of go into here and go into here and then essentially run this again. Ah, there we go. So it works. Okay, okay. But thank you. Thank you for your encouragement, Stephen and Herman, not rushing me. So, okay, so yeah, so to test it too. So basically we can do a post, right? Let's add an item to cart, right? But actually first let's do a get. So at this point, we can run it and try it out in here. And if you execute, you see that it comes back, right? The response body. And then this is the header. But the thing is that in the response body, you do not see anything because we haven't added anything yet. So, okay, so now let's go to this other method too, in which we're actually posting, adding a new item to cart. So, okay, so over here, we can say add, let's say items you need for intergalactic level. How about some bananas, something? And price for this item, we can just say 1088, something like that. So, okay, so with that, we can execute. And as you can see, it's basically doing a curl, doing a post. And over here, that's the one, right? The banana and then ampersand and then 1088, the item ampersand and price. So, and this is the request to kind of do it. And now the response body was basically saying that it's added to our cart. Okay, so that's good, all good. We're getting 200 essentially. It's all good. Now let's go to the this part now to see what's on the cart, and we can execute. Now, as you can see, this works, right? So you can see the cart in here. We'll get bananas, and then essentially, colon and or actually the what you call it, the offset. Okay, anyway, the separator, and you can see 1088, and then the subtotal too at this point is 1088. Now, if we want to add more, now this is kind of just for testing, right? So we can just say add some apples for like $200.12, something like that. I mean, it's kind of a little bit kind of fictional, but okay. So we see apples is added to our cart and costs $200.12. And now if we execute and see, okay. Now we can see apples to $200.12 and the bananas are 1088, and then the total will be 211 in this case. So, okay, so this kind of conclude, this particular example, and what a kind of myself too, kind of like having a bit of a risky, but thank you again for encouraging me to get this going. So hopefully it's not like too much kind of veer us off course. So, and as such too. So this is that one, and let me kind of go back to playing the slide. So the other example here, which we won't have time, is basically a stateful kube demo. Is stateful Kubernetes that are making use of stateful set and also using Nginx for doing the ingress too. So you're welcome, everybody, to go visit this and take a look into the example under this particular link. So on my GitHub. So. And okay, so with that kind of comes to the end of my presentation. And these are some of the links, for the resources that you can look up if you're interested to further, understand this topic area. So here I list out the code samples we worked on, and also the Saga design pattern I take from Chris Richardson's site, the microservices.io Saga. And also profile the long-running action too. This one, I give you this link so you can also take a look into the LRA description. And then also, there's also a blog written by the developer who is working on it. He published a blog, and it's really actually pretty nice too by Jason, this developer. So please also take a look. And then the OpenLiberty, the links to all the OpenLiberty guides too, and microprofile and Jakarta EE. And then there's also wanted to point out too, there's developer.ibm.com because at such IBM, you name it, we have all different types of software in the world. We have it, right? Even quantum, if you're interested in it, Watson, all these things too. So there are many other things if you're interested. And our cloud, links to our cloud DevOps, the cloud native information, and programming with Java on the IBM Cloud. There's also some documentation on it too, if you're interested, but this is just FYI. So, and then also then there's a Cloud Native Computing Foundation where you can find more about Cloud Native too, and then the 12-factor app too. And also too, I mentioned about me doing a Twitch stream. So I usually do it every Wednesday at about 1 o'clock, 1:30 US Central Time. So that would be, I think, 7 hours. So it's about 8:30 your time in the evening. And there are also other streams too, not just the Java Cloud Native stream, which I kind of used to be doing more reactive. Now I switch it more into Java and Cloud Native, and any other things too by request. If you want to visit us on twitch.tv, IBM Developer, you're welcome to. And then also public cloud too. If you want to go to cloud.ibm.com, you can also get a free cloud account too. And then also there are also, I'm sorry, I know there's a whole bunch of stuff, but there are also other kind of IBM Expert TV things. Again, all of these, it doesn't cost extra. So everybody is free for all. So that's why I thought I'd share. We're not asking you to buy things. It's more like we're just wanting to share. And IBM is more of an open source company than what it once used to be, right? Suit and tie, but it's no longer like that. So, so that's the thing. And then there are also other IBM developer meetup groups too on the meetup.com. If you want to search for them. Right now with COVID is anybody can watch anything from anywhere in the world too. I like to recommend to San Francisco Bay Area. They have actually quite consistently, they produce a lot of different meetups too, and also my Chicago Jug too. And please come and join us too. This week, in fact, Thursday, we're gonna have a talk by two Eclipse committer, one Java champion, Hendrik Ebers and Karsten Toms. They're gonna compare microservices framework. So if you're interested in Quarkus, Spring, the reactor, or even just like Spring microservices, and microprofile, and also one more, Micronaut. So they will be comparing these for microservices framework if you're interested. And also, there's also a call for code at IBM. This one is actually a global hackathon. Is once a year they're running it to really like help with kind of for a good cause. And then also you can form teams, and their prize money is pretty generous. As you can see, top winning prize is $200,000 US too. So if you want to visit that. And okay, so with that comes to a close, and thank you so much. And I also have a Discord server if you want to follow me on there. As such, this stateful microservices, reactive, all of these are full of opportunities and solving life's most complex, or among the most complex type of computing problems. I feel I'm just so interested in it. There's just so much to learn and do and share. Please join me on Discord. There are also other developers in there if you want to continue the conversation. And then these are my other links if you want to follow me on Twitter, on LinkedIn, my GitHub, and also on my dev.to blog site too. So, and I also see some chat from folks, right? Let me see. Oh, thank you. Yeah. Oh, thank you, Hendrik. Thank you, Ahmed. Thank you. And thank you for being patient with me too. Oh, thank you, Derek. And okay, thank you. I thought there might be questions too. So if you have any questions, please, feel free to interact too. I always like to have conversations. So thank you so much. And again, Herman, thank you so much. Stephen, thank you so much for your patience with me today. Thank you again.
It's really been a pleasure having you here. Thank you, Mary, for sharing your knowledge and your time.
Thank you.
Is there anybody with questions? Just remember to unmute yourself, or you can ask in the chat if you're shy.
That's right. It is interesting, right? And that's what I'm finding too. It seems like developers tend not to like to talk. So, yeah. But that's okay. That's all okay.
In South Africa, we're quite a shy bunch. We're not as talkative as in the US developers. I think we ask less questions, and yeah, it's interesting dynamics, but different.
Yeah.
Yeah.
That's right. Yeah. Thank you. Yeah. Yeah. Thank you. I think it's probably also a general observations I have too, even in other countries. And but I do have to say, interestingly, in India, I was just there for the GITS conference in Bangalore. But over there seem to be more folks like really asking, wow, like nonstop for a while. So that was nice too. Yeah.
That's great.
Yeah. So that's good. But otherwise too, even in the US, sometimes I find it's not like that people also in general, maybe just quieter or something. So yeah. So yeah.
And thank you. I must say I haven't played with OpenLiberty, and I'm quite excited to do that after this.
Oh, great.
Yeah, it looks really great.
Yeah, that's right. And as I
get it going now.
Yeah. And as I mentioned, too, OpenLiberty is all open source, and anybody, if you're interested in joining an open source project, that's all open too. So, yeah. And please feel free to connect with me if anything. I can connect you. And Microprofile, same thing too. There's a working group on Eclipse in the Eclipse Foundation, Jakarta EE, all these. Yeah. That's right.
Ivar is one of those.
Yeah, that's right. Yeah, Ivar.
I've met him a few times. Yeah. Awesome. Yeah. Thank you, Mary, and Steve, for organizing it.
Thank you, Stephen. Thank you, Herman. Thank you so much. I appreciate it. Yeah, thank you. Yeah. Wonderful.
Thank you, Mary. It was so informative. Yeah, I think also I will have a look at the repo, clone the code, and let's start this.
Yeah, sure.
OpenLiberty.
Yeah, thank you. Yeah, okay. Wonderful. Do you usually hang out for a little bit, or maybe folks starting to leave, right? Is that how it works?
This is where before the Zoom meetings we would have some wine and snacks, but people tend to rather leave on Zoom and not hang out too long.